Hi, Kira. I thought I would just hop on and try to do a quick video to take you through that quadratic regression. It's exactly like the linear regressions that we did in module 1 in terms of how it begins. And so what we're going to do is take this data set. You have to decide what are the inputs and the outputs, or the X and the Y's. And then we're going to go to the calculator. If you go back and look at linear regression videos from module 1, or you can go onto the side menu in my math lab and pull up the one that talks about calculator videos and look for the term regression and watch that video if you need to watch another one. But I'm going to shoot you one that's right for this particular example. I'm going to do the example right here with these numbers instead of the one in your actual problem, so that you can use this video to kind of help you through your actual homework problem. Okay, so what we're going to do is notice that they have the table labeled very nicely. It doesn't happen to be a word problem where we have to think about subtracting the initial year or anything. The X values up here, 0, 2, 4, 6, 8, 10. Those are my inputs. And then the F of X, which also means the Y values are the bottom, the bigger numbers, 0, 400, and so on. All right, so what I'm going to do first is I'm going to go into my calculator. And in order to do regression, we have to have values listed in the input and output data sets, which are list 1 and list 2 in your calculator. So I'm going to stop sharing this, and I'm going to go to the calculator next. Okay, now what we're going to do is just put those values in. I took a picture of them a minute ago so I could see them. All right, so all of this starts from the stats key right over here. So when you hit stats, if you want to put data into the calculator, that's the edit feature. So we always start with stats edit, and it's going to pull up all the different lists that you could have. And you can see that this is something that was from, let's see, I think I was practicing this before. When you want to get rid of old numbers, you go up to the list, the name of the list, and then you hit the clear button, and then you hit enter. I'm going to go over here to the same thing. List 1, I'm going to clear. Actually, those might be the numbers I need. Anyway, that's how you get rid of your old list. Remember, X is going to go in list 1, Y is going to go in list 2. All right, so for that particular example, which was just like your homework problem, the X values were, yeah, that's what I had before, 0, 2, 4, 6, 8, 10. So we're just going to put those values in for the list 1, which is what the calculator assumes it's going to treat as X values. Like if it needed to plot points, it would use these as the X value of that point. All right, now I'm going with that view and example values. So 0 and 400 and so on. So 400. And when you're watching one of these videos, you can always pause it and have your calculator out and go through and try and do the same steps as we're doing them, as I'm doing them here in the video, and then you can start it up or rewind it a little bit to make sure you're following along, getting the right numbers. 1605, 3605, 6407. You just hit enter to move down the list. All right, now I always do a double check here because I know myself well enough to know I'm likely to make typos here when I'm putting this data in. 6, 13, 5, 8, 6, 4, 7, 10, 9. Okay. So I do have the data entered correctly. So this is the same table we had in the homework problem. It's just listed vertically instead of horizontally. So once you have your data listed or entered, it's always helpful to just go back to your main screen before you do the next step. You don't have to, but I'd like to get out of the data edit area. Okay, so now it said, do a quadratic regression model. Okay, so to get to regression, that is part of our statistical package. So we start from that stats button again, but this is a calculation that we do on those two data sets. So we're going to go over to calculate, and it has all kinds of things you can do to a list of numbers. And the first 3 aren't regression, but once you hit number 4, all of the next several, 4, 5, 6, 7, 8, 9, I think the next one is exponential. We're going to use quite a few of these during our course. And so in module 1, we were primarily studying the equation of lines. So we focused on data that gave us a linear shape. And so we asked for linear regression. But in this one, we're looking at functions that have some curvature to the graph. And so it asked us to do quadratic regression. So this is the only place where it's different from what we've done in module 1. You enter X into list 1, Y into list 2. Then we go back into the stats menu, we go over to calculate, and we're going to select number 5 because that's the one that says quadratic regression, number 5, right there. Okay, now from here, it's going to look a lot like it did before. It's going to tell you, it's reminding you that it's storing what it thinks the X list is in list 1, and the Y is going to go in list 2. I guess that's in case you had multiple lists and you were trying to, model them against each other. If I wanted to store the regression equation already assembled, you know how it tells you A and B and C equals the values, and then you have to round off those values to whatever you like. The most accurate version, of course, would be to use all the decimal places, but it's also the one that's, most time consuming to copy all those values down and then turn around and type them in. So the store regression equation is just, if you wanted to use all of the decimal places and also assemble it into the A value number times the X squared and so on, the store regression would do all that for you. I'm going to skip that for now because it did in this problem ask us to round off our answers. So I'm just going to go down to calculate. Okay, so here's what we've got. We need to round these values to either whatever decimal place or significant digits that it asked for, and then assemble them according to, it tells you, kind of gives you a blueprint up here. So for if we were just going to do for the, I don't know, the 10th place, I'll have to go back and look and see what the problem says, but we would do 99.7 times X squared plus we'd round that one up to 9 times X. And then since C is negative, I would say minus 1.8. All right, let me see. I'm going to go back and look at the problem and see what it actually asked us to round it to. It did not say. So let me go and actually, I was looking on my phone. That was not accurate enough. Where did that go? It's rounded to 2 decimal places. Okay, rounded to 2 decimal places. So I need to get off this and get back to. I'm still on the, where is it? Yeah, I'm still on the calculator. All right, so if we were going to write this out on our paper to this 2nd decimal place. All right, so the answer would be Y equals to 2 decimal places. We're looking at the 2 here. We have to look at what follows the 2 to decide whether to keep the 2 where it is or round it up. All the values before the 2 are exactly the same. So it's going to be 99.72 because it's followed by a 3, and that's not big enough to move it up. So 99.72, and then it says that's the number that you take times X squared. Okay, the second number, 2.85, because the 5 is followed by a 3, which would not be big enough to round up the 5. So 2.85 X, that's what this says right here. And then minus, because the C value is negative. And the second value here is an 8. And it is followed by a 5. And anything that's 5 or greater will round up the previous place value. So that would be minus 1.79. All right. Now let's see how we did. That's what I wrote. So I'm going to go back to the view example we were doing. Just kind of hit the button and see what we got. All right, so they put the things in list 1, list 2. They did the regression using something. All right, so here's the rounding. I rounded mine 99.72, 2.85, and minus 1.79. Yep. Okay, so you have to round these on your own, and then you have to write them like this, assemble it all together into a final function. Now, if you look on the homework that you're going to do, your list 2 is going to be different. You're going to have these numbers in here for list 2 instead of the ones that I did. And you will just have to round the numbers and just type the coefficients in here. They have been kind to you and just wrote the structure of everything with the X squares and the X's and everything. Notice here in this last one, it does say plus out in front of it, but remember our C value is actually negative. So you would write your negative, whatever the number is. I'm assuming that this will have similar types of values. If any of your values are negative, they already have the plus signs in front of the term, so you don't have to put the negative in the box. Okay, so that's how you do a basic regression. The X value goes in list 1 in your calculator. The Y value goes in list 2 in your calculator. You get to all of that stuff starting from the stats button. When you want to put data in, it's edit. After you have the data in and you want to actually get these numbers that form the model, then you will go to stats and go over to calc and then select quadratic. So let me show you what it would look like, kind of put it all together on our calculators. All right, it didn't ask you to do a scatter plot, but when we look at data, a lot of times we want to look at the scatter plot first. So once you have your data in here, which I'm just reminding you where it is, once you enter the data in there, if you want to see the scatter plot, whenever you're looking at a graph, you go to the Y equals button because that shows you what you're going to graph. And the easiest thing to do is just to use your arrow button to go up to where it says plot 1 and then hit enter to highlight it. And that means the calculator is going to graph the points. Now you still have to have your window set up to where you see the points, because like wasn't one of the points like had a Y value of 9,997 or something. So if you plot those in the standard viewing window, you're not going to see any of them. So our calculator also has a little quick zoom feature that automatically resets the window when you have data entered in like this. So if you go down here to zoom stat, which is the 9th selection, it will look through your data sets and readjust the edges of your window, your X min and max and your Y min and max, just big enough to see all however many points, 6 points, 7.6 points, 1, 2, 3, 4, 5, 6. So now when you look at it, this is why the problem is asking for us to do a quadratic model, because it's got a little curvature to it. We could have also tried to do a linear model, even though linear lines don't have any curves, and it would do its best and it would fit a line that's very straight that would kind of be an uphill line going through here somewhere, but it really wouldn't fit the behavior of that curvature as well as a quadratic model would. All right, so once you have gotten your quadratic model, I'm going to just show you what we're doing here. The homework problem doesn't ask us to do any of this. It only asks us to write down these coefficients that form the function. So, and again, remember, this is the data set from the example. It's not the data set from your problem. Not. But those are my values. I rounded to 2 decimal places. Oh, I left out the X in front of it. At the end, 2.85 times X. So I'm going to insert the X. All right, so there's my A, B, and C. The A is supposed to be multiplied by X squared. The B number is multiplied times X. And then the C value is just a constant term. So that's what a quadratic function looks like. So it said use quadratic regression to find a model for this data. There's our quadratic model. Now, if I graph this, we're going to see a blue curve kind of plot pretty much along that same path as those points. You know, those points look like they are pretty close to fitting that curve. So that's a pretty good fit right there. The only one I can see, it looks like it may be just a teeny bit low for that second point. But when you have real data like this, it's not going to fit a perfect pattern. You're just trying to look for the trend that the overall group of points tends to represent. So that's a pretty good, that curve, which is a quadratic, the right side of a parabola base. You can see the turning point looks like it's around here somewhere. But at the right side of it, does fit through those points, that behavior, that scatter plot pretty well. So that's just a real quick visual check of how well that fit. So if we wanted to go and just look at the next problem, just to make sure you're kind of understanding what we're doing here. I'm hoping that this works. Actually, I'm going to go back to your main problem and click on number 3, because I just want to make sure that I'm getting the right problem. Wait, I don't think it's sharing. Number 3. Let me open that. I'm going to stop and start to share one more time. Stop the share and then share number 3, which is right here. All right, actually number 3 is exactly the same way as number 2. It's the same problem. So let's look at number 4. Pay attention to how it wants you to round off your answers, because this one isn't by decimal places, it's by 4 significant digits. So read that and kind of figure out what it wants you to do. Significant digits means you start from the very first number that you're looking at, place value, and you identify the first one as you move from the left to the right that is not 0. So if the number starts off 0.0, 1, 2, 3, 4, the first significant digit is 1. You ignore that 0. So anyway, that's a little bit different, but also a lot of the word problems have the input units are based on time in years. And so it'll show you the whole year in the data set, but somewhere when it asks you to do the model, with mathematics, we like to work with smaller, easier to plot numbers. So don't type the whole year in for list 1 if it gives you directions to do something different for X. So look here, it says A, create a scatter plot of the data with X equal to the number of years after the year 2000. It doesn't say X is the year, it says X is number of years after 2000. So that's kind of your start year. So basically you just figure out the difference between each of these years and 2000, or it's the same thing, it's just subtracting 2000 from each of these years. So this X data set that goes in list 1 is kind of like the ones we were just doing. If 2000 is my start year, that's 0. That's when the clock starts running. So the X values I'm going to put into list 1 for this top row are going to be 0, 10, 20, 30, 40, 50. So pay attention when it asks for the model, what it wants you to realign that input data so that you can put the X values into your calculator correctly. You'll know it's done incorrectly if you get the first number right, but the other numbers are not right. That usually tells you that you didn't rearrange your X data like you should have. Okay, well, I hope that helps a little bit. Let me know if that's not clear, if you have other questions.